Hi, everyone, and welcome to Unit 9 of IHMN 315 Research Methods. For this week and for the next week, we're actually going to be taking a look at analyzing the data, and we've split it up into, the natural setup of quantitative and qualitative. So I'll be doing quantitative this week, and then Dr. Brian White will do qualitative analysis next week. So that's the way that we've set this up. To begin with, of course, we'll do a little bit of in the news, and I'm sure those of you that have been paying attention to kind of anything will know what some of the stuff that's going on in the news. And then we'll take a look at analyzing the data. It's just kind of a general comment, and then specifically looking at quantitative analyses. Right. So, so what do you think has been happening in the world? Well, of course, the thing that's been dominating the news everywhere this week has been the Biden-Harris winning the White House in the United States, the U.S. presidential election, and I'm recording this right now on Saturday. So at this point, they just called it, although, of course, it's not official until everything has gone through. But at this point, all of the news networks and everything are giving the 46th presidential win to Joe Biden and Kamala Harris. Lots of historical aspects to the election. So take a look at that. Why are we bothering to pay this much attention to an election in the United States? Well, there's all of the obvious ones about the impacts on a global economy, tourism, everything else, the fact that they are our next door neighbors. And so what happens down there, we're greatly impacted in all sorts of areas and directions and things like that. The other thing, if you're a bit of a data geek like I am, wow, talk about numbers to play around with and taking a look at, thinking about the odds, um, percentages, ratios, thinking about demographics versus psychographics, and all of the voting blocks and everything like that that's been going on there. If you have any interest in data and numbers and everything, there was certainly lots to keep your interest this past week. The other thing that's occurring is a real questioning of how polls are done. And so there might be, again, some more implications from that comes out of that. Of course, meanwhile, the coronavirus, COVID-19, has not let up anywhere. And in fact, there's been a few more surges across the world, and particularly, again, here in Canada as well. Here in British Columbia, we've noticed a bit of an uptick in the numbers of COVID-19 cases. Here on the island, we've been lucky so far. We've only got a positivity rate of about 0.5%, which means less than 1% of all the people that are being tested at the moment are coming up positive. So that's a good thing. But we cannot, I guess, we're not isolated enough, we're not separate enough to be safe or secure. So it's something that we're definitely watching. And you think about that and all the implications for tourism and hospitality. And Destination Canada, looking at some of those implications and looking at the tourism industry, and they were noting that European travelers seem to be some of the most confident about international travel at the moment. So, um, right now, that seems to be where the market is when it comes to international travel. Within Canada, though, outdoor destinations seem to be faring the best. They seem to be doing the best across Canada. In particular, for example, places like Tofino and Ucluelet, a little bit away from places. Um, Even some of the places in the Okanagan and Kelowna, Kamloops, uh, the Banff and Jaspers, just out of the big cities where there's more space, that seems to be where people are going. So that might be the trend for the next little while. And all of your bigger cities, your bigger events, any sporting events, festivals, things like that are definitely having a much more difficult time at the moment. So you've collected all your data, and now what? What does all the data actually mean? And this is where it becomes so critical in the whole process because there is not only the analysis of it, of all the data, but the interpretation of it. And interpretation is a very critical part in the whole process, basically making sense of the information and relating it all back to your research questions and your research objectives and the goals for your whole research. So this is where, when you're doing your research projects, making sure you loop everything back and check to make sure that you're actually answering all of your research questions. Something else that's kind of somewhat more recent element when it comes to data analyses is something called big data. And you may have heard of big data before, but if you haven't, big data is essentially when you start combining more and more data sets, you find kind of a common element where you can connect different data sets together. And nowadays, um, with computer systems and even starting to use something called artificial intelligence in data analysis, you start finding out all sorts of relationships and different understandings of what's going on, and connections that you might not have otherwise realized. As a very quick example, uh, back when I worked with Destination Canada, we had access to these huge data sets that we were connecting up with the Explorer quotient to the point where I could find out exactly where our target markets were in all sorts of locations across Canada, the United States, various other locations around the world. We knew where these people lived, where they worked, what routes they took to get from home to work, what activities they did after work, what magazine subscriptions, everything. And because we had this level of data, we could do things like putting up a billboard on the side of the road that they would see on their way home, promoting, that they, rather than being stuck in traffic on a Los Angeles freeway, they could be relaxing in Canada, things like that. And now you connect all of those sorts of different data sets up with all of the advertising on social media, and you can just imagine where you go with all of those. Anyways, there are 3 different TED Talks for you to check out, and kind of some interesting things to explore when it comes to big data, especially those of you who like quantitative research. Just some very quick basics about analyses. Quite often, of course, qualitative and quantitative information or data is examined in different ways. While there may be some overlap, how you deal with the information is quite often very different. However, you will, and some of you, I think, in some of your research proposals, talked about the idea of mixed methods research, and we've talked about it before, combining a bit of qualitative and quantitative together to get a much better understanding of your problem, of your situation, of your opportunity, things like that. And they can be combined in a variety of different ways. So, for example, you could start with a quantitative survey, asking people, finding out what people are planning to do, where they're planning to go, things like that. But then you may follow up with some qualitative surveys, some qualitative interviews, focus groups, things like that, just to get a much better understanding of some of the whys. So with your quantitative, you may get kind of a broad understanding of what's happening, but you may not understand the why. Or you may flip that around and start with qualitative research. So doing some focus groups, doing some interviews with people to maybe better understand what sort of activities they plan on doing over the winter. Once you've got a good understanding of the situation, then you follow up with some quantitative research, quantitative survey, just to better understand how big potential markets are. So again, that combination of qualitative and quantitative just giving you a much better picture and potentially using that to triangulate and understand what you're looking at. This week, we're only going to look at quantitative analyses. Next week, Brian will look at qualitative analyses. So just kind of an understanding of once you've gathered everything, once you've done all of your surveys, what do you do with it? What do you do with all that data? Just some general thoughts, some general considerations. Whenever you're doing quantitative analyses, it's good to have prior experience with basic statistics and some good understanding of relevant computer software packages. And actually, your textbook does a really good job of taking a look at something called SPSS, which is a very specialized sort of data analysis software, statistical analysis software. Now, unfortunately, for the most people, it's very expensive. As a student, you can get student packages, but even then, it's moderately expensive to get them. I had access to SPSS when I worked with the government, and I could do all sorts of different data analyses. But at home, I do not have access to that because there are several $1,000s to get the full different packages. So what's important to understand, though, when with any of these sort of data analyses, is that you really have to understand the data. You have to understand the types of analyses you're doing, because you can do all sorts of different things with those computer packages. But it comes back to that whole thing of garbage in, garbage out. If you really don't know what you're doing, you can press all sorts of buttons. You can input all sorts of information and have it spit out different things. But as for it being accurate or correct or anything like that, not necessarily. Because it's so easy to do it, it's very easy to do it wrong as well. So if you're ever in doubt, make sure you go to somebody who does have that sort of quantitative data experience. And it's not for everybody. As a very quick example, within our School of Tourism and Hospitality Management, most of the people in our school are more into qualitative data analysis. There's only a couple of us, myself included, who really do quantitative data analysis. And so it's not as common, at least not within our school. Very important thing to remember is that you really want to make sure that you're considering how you're going to analyze the data when you actually are in the design phase of your research. While you're working on your research methods, things like that, while you're designing your questionnaire or uh, anything else that you might be using to collect your quantitative data, you really need to think about how you plan on analyzing it. Because depending upon how you ask questions, depending upon how you set up your survey, that can really affect how you analyze it afterwards. And if you only think about that afterwards, you may miss out on opportunities of different ways to analyze the information. And once that data is collected, you can't go back, or you very rarely can go back and try to recollect that data. Other things to think about when you are setting things up is trying to minimize the number of steps between the collection of the data and the ability to analyze that data. So the more often that you can have that data directly entered into your data set, rather than you having to do it manually or other steps in between, the more accurate it's going to be. The fewer opportunities there are for errors in the input of the information. So that's definitely something. And the easier it is for you, if you can have that data directly entered into the data set, then you're that much quicker to analyzing the information. Very quick example of that is using the SurveyMonkey, where when the people are filling out the survey, when they're answering the questions, that data is being automatically and directly entered into the data set, which means it's a lot less work for you to start the analysis process. When you're looking at a data set, the usual way of seeing it is each row is considered a single respondent, and each column is each one of your variables. So you can see by this table here, patient 1, 2, and 3, those are your rows. So those are your respondents. And across the top of your data set or your table, those are the different variables you might have been looking at. So gender, age, their weight, height, whether they smoked, and what their ethnic background or their race. So, and just to kind of point out one very quick thing, you'll notice in the smoking column, they've used 1 for no and 2 for yes. And that's a very common sort of thing to see, where you'll have a number representing a group or potential response. And that's different from if you look in the very first column, under gender, M and F. Now, with this kind of brings up a very important point with things like gender, and it's the collection of things like gender, age, things, and other certain bits of information. There's been a real shift in understanding, a real shift in the way that these questions are asked. And so, to be very clear, gender no longer being gathered as just male, female. There's a variety of different categories that can now be, and or for some of these, prefer not to answer. So it's something that you need to really think about again when you're setting up your questions, when you're setting up your different data, is to really be very conscious about how you need to gather that data. Something else that also makes kind of highlight is, what do you do if somebody doesn't answer a question? So you ask a question like, how old are you? Or what year were you born? Because actually, you're much better off to ask, what year were you born? People are more likely to answer that than to give you, to identify how old they are. Even though you still get the same information, people just generally find that answering what year they're born is much less invasive than to ask how old they are. Anyways, you ask, what year were you born? Somebody leaves the question blank. What do you do? Well, first off, hopefully you've designed your questions to kind of minimize the possibility of that happening. So you give them opportunities to say, prefer not to answer, not applicable. You give them options. If they do not answer anything there, though, you actually have to leave that as a blank or a non-response, because if you can't assume that when they've left a question blank, that actually meant one thing or another. You can't assume that it's a yes or a no. You can't assume anything. All you can understand from that is that they chose not to answer that question. So when it comes to the analysis, this is just kind of a very quick example. If you had 100 respondents, 100 people answering your survey, for most of your questions, maybe you would have your responses out of 100, but if somebody does not answer a question, that question you now calculate out of 99, or however many people did not answer that question. So again, it's handled very differently than if somebody does answers by not applicable or don't know or choose not to answer or anything like that. They're very different responses. Very important, before you start any analyses, is that you need to clean your data. And by cleaning the data, you're actually looking through all of the numbers, and you are checking to make sure that there aren't any blanks that there shouldn't be. that somebody didn't double enter in one spot, that somebody didn't just run the field, or, for example, mark one for everything, whether it made sense or not. Situation like that, if somebody runs the field, you actually delete that respondent. That respondent is no longer valid because you can't trust what they answered. So you can delete that whole respondent. Other thing to look for is things like maybe you're looking for what year were they born, and somebody marks down 2020, which clearly they could not be born in 2020 to be able to answer the question. So sometimes you can guess what they meant. For example, somebody might put 965, meaning 1965, but they forgot the one. You can make those assumptions. If you're ever not sure, though, you actually delete that response. If somebody makes a mistake and you can't figure out what the real response should have been, you just delete it. The other thing is, as I say there, looking for outliers or something inconsistent. So, for example, you might ask for a question about what is their income level. And if you get a bunch of people going, yeah, I earn over $1 million, you can probably assume that, at least for that particular answer, that's not a true value. So you either delete just that response, or if there's any concern, you might delete the whole respondent. So the goal of all of this is to make sure that the data set that you're working with is as accurate and as clear and as usable as possible. When you're looking at quantitative data, quite often it's, and we've talked about some of this sort of before, with quantitative, it's often exploratory or confirmatory, as in you're trying to discover something. With exploratory, looking into just to see what's there, just to understand. Or confirming is where you've already got some ideas, you've created some hypotheses, some predictions of the way things might occur, and the data and the types of analyses that you're doing with the data, you're trying to just either confirm or deny your ideas. So, for example, you might think that people with higher income across Canada are more confident and more likely to travel within the next 6 months. So you might go out and survey a bunch of people and compare people with a higher income with people with a lower income and take a look at their likelihood to travel in the next 6 months. So there you had an idea, and you want to either confirm or disprove your idea of the way things are. Quick example or case example: if you take a look in the Moodle shell, there's a report there from dredge number 4. It's a National Historic Site up in the Yukon. You can see at the bottom of the slide, there's a YouTube video that you can check out to just get a better understanding of what that research was. I conducted this research when I was working with Parks Canada. This was way back in 2003, using paper surveys and part of what was called a visitor information program or project. And we were trying to understand, why were people coming to this dredge number 4? Where were they from? What were they learning? What did they like, dislike, everything like that, so that we could better manage the that National Historic Site. So if you get a chance, take a look through the report, go through some of the different slides and that are on it, some of the different charts and tables. And as you're going through it, just start thinking to yourself, okay, if you were running this, if you had just done those analyses, what are some of the key things that you might learn from conducting that research? If you were the manager, what might you do differently if you had this information? And what recommendations might you make to your managers based on that information? So I just wanted to give that to you as an example. If any of you want to chat with me about it and some of those implications, let me know. Okay. For the fun part, statistics. And there's lots of things you'll read and write about statistics. You see, Mark Twain, facts are stubborn, but statistics are more pliable. Someone by the name of George Box, all models are wrong, but some are just useful. Statistics really can be a complex field of math and things like that. It's not for everybody, that's for sure. I guess one last quote I wanted to show you. Someone by the name of Benjamin Disraeli said there are 3 kinds of lies: lies, damned lies, and statistics. So depending upon how you analyze the information, depending upon how you interpret your data, your statistics, you can come up with very different responses, very different answers, very different conclusions, depending upon how you work the data. So that's why for all of you, it's important for you, even if you don't become statistical whizzes, even if you don't become experts in statistics, that you at least you need that understanding of statistics and what the different analyses are and do and things like that, so that if you're ever reading this information, if you're ever getting this information, you are a better consumer of the statistics. It's a very quick, I guess, sidestep. Just wanted to highlight something called statistical significance. And at times, especially when you're reading some research reports and things like that, especially journal articles, they may talk about statistical significance. And as just a general comment, it's good to know what statistical significance is, but it's not always, especially when it comes to real world research, it should not necessarily be your focus. And there's statistical significance, and then there's what does it really matter? And that's where, as a business person, as a manager, it's important to be able to distinguish when something is really significant as opposed to just statistically significant. Anyways, some of the things that you may see when they're talking about statistical significance. They'll talk about testing the plausibility of a null hypothesis, which means, is there really a difference between two different populations? Is there actually a difference between the way a college student and a university student um, choose their travel patterns? Is there really a difference between um, men and women in their leisure activities? So you'll have these different hypotheses, these different ideas, and you're wanting to see, is there really a difference between these two different groups? Trouble is that that difference, while you may have a statistical significance or a statistical difference between, in reality, you may discover that that difference will not change what you actually do, some of your managerial decisions. So that's where it's important to really highlight whether or not that statistical significance is actually significant when it comes to operational decisions. All right, so exploring the data set. Some of the stuff that I'm going to talk about you may have heard before, but it's important for me to just go through and make sure that everybody understands it. There's lots of different ways for you to slice and dice the data. There's things about frequency distributions, different numbers and means and medians, modes, and all sorts of different things. And one of the very first questions that I like to ask people is, between mean, median, and mode, what is the most important? And quite often people will say, well, the mean is the average, because it's really important to know the average of this data set and things like that. At which point I point out, okay, so if I put one of your hands into boiling water and one hand into freezing cold water, such that the average between those two bits of water is a nice 20 degrees Celsius, does that mean that you are comfortable? Well, of course not. But just because the average tells you one thing, it doesn't necessarily give you the best response. So it's important to understand all three of them. The mean being the average, where you add up everything and divide by the number of numbers. The median is the midpoint of all the data. So what you do with the median is you put all of your data numbers into order. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You make sure that they are in order, and you choose the middle number. What do you do if you have an even number of numbers? Well, then your median is now the average between those two middle numbers. So the median of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is actually 5 plus 6, or 5.5. Then mode is the most common number in your data set. So if you had 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, your mode is actually 1. because it was the number that showed up the most times in your data set. So, but each one of those three different types of ways of looking at your data can create very different numbers when you look at different types of data sets. So you can see if you have what's called a normal distribution, which is that nice little curve in A, or they sometimes call it a bell curve. If you have a nice normal distribution like that, your mean, median, and mode should be right in the middle. They should be all the same. No problem. If you have something like in B, which you would call a bimodal distribution, bi meaning two, which means you've got two humps, like a two-humped camel. In that case, you can see you've got two different modes, but your mean and your median are at the same point. Then you have situations where C and D, something called skewed. So either skewed to the left or skewed to the right. And in those situations, your mean, median, and mode are all different. So you can see how all of these different ways or these different types of data sets, if you understand what mean, median, and mode are, may give you different understandings, different interpretations of the data. And it may lead you to different conclusions of what that data means. Other things to think about when you're talking about data. You have measures of spread, basically how wide are these numbers, how different are they from each other, things like that. And to measure that, you have what's called variance, standard deviation, or your range. Variance and standard deviation are very close to each other. And basically, they're talking about if you know what the middle or the average, how far off are all of the numbers from that average? So that's what you're figuring out there. How wide is your curve? How different are all the numbers from everyone else or from the middle number? Range, of course, is just what's your smallest to your biggest number. Then you have things called on your measures of shape, skew, and I've actually got some images that I'll show you in just a moment, but you have skew and something called kurtosis. So skewed is whether or not that top of that curve is pulled to the left or pulled to the right. And kurtosis is how high is that peak? How tall is it? To show you here on a graph, when we're talking about that kurtosis, you can see the blue curve is higher up and the red curve is more flattened out. So those are different. Now, both of those curves are equivalent or fairly average. If you take a look at, both the left and the right-hand sides of both of those curves are roughly the same. So neither one of those curves is skewed at all, but one has is higher peaked or has a higher kurtosis than the other. And when we were talking about that variance or standard deviation, So we're talking about how spread out from that center line are all of your responses. So you want to talk about that distribution, how far out from the center. And here's some examples of what that skewed looked like. And you probably have heard the term skewed. Oh yeah, that's skewed. That response is a bit skewed. Well, that means that it's not, it's kind of pulled to the left or pulled to the right. It's not necessarily your typical type of response for this question. A few other things to think about when it comes to analyzing your data, quantitative data. And I know this is a lot of things to think about. Your textbook actually does a really good job of going through all of this. So definitely take your time reading through the textbook on this chapter. They've got some really good information there. If you're trying to take a look at connections or one group versus another, you'll do things like that are called crosstabs. So for example, comparing perceptions of people from Mexico versus perceptions of people from the United States, what they think about Canada. You may do a crosstab there. You may do a crosstab comparing men and women on their spending habits or their perceptions of your destination. There's all sorts of different other crosstabs you might run. So basically just putting your information into a table and taking a look at whether or not there are some links and some different, I guess, connections that you might not have understood or might not have expected. When we're talking about correlations, you've got something that's called a perfectly negative correlation or a perfectly positive correlation. Perfectly negative being a -1 correlation coefficient. A perfectly positive is a +1 relationship. Now, again, may not make sense at the moment, so sort of thing might look like. Strong positive correlation, you see that those dots forming that nice little line up. So, maybe that's a positive correlation between satisfaction and the amount that you're paid. So as you're paid more, your level of satisfaction goes up. And so that there's that, nice steady line, more and more, it goes higher and higher, the more and more you get paid. Then you might have a mid where, maybe it isn't quite so clear, that correlation, still positive, but maybe there's other factors that you haven't considered in that sort of relationship. Or maybe there's no correlation at all. For example, maybe there's no correlation whatsoever between satisfaction and days of the week that you work, things like that, whether you work on weekdays or weekends. Who knows what that sort of correlation, what different things that you want to compare one group versus another. But it's interesting when you do start to look at these different bits of data and looking for some of these correlations. Then you may have a strong negative correlation. So um, as prices go up, the likelihood of you purchasing maybe tickets for a sporting event go down. So, when your ticket prices are really low, the chances of you purchasing are very high. But of course, as that price goes up, the likelihood of purchasing goes down. So that would be a strong negative correlation. And then sometimes you have that curvilinear, which could curve either direction. It can curve, you can see in that example, it goes down and then back up. Or it could go the other direction where your curve goes up and then drops down. So there's all sorts of different relationships that you can discover when you're looking at the data. Just wanted to, I guess, highlight the fact that yes, if you've never played with data, if you've never done any of these sorts of analyses, it can be very confusing. And for this course, it's definitely more than you really need to know. We're not expecting you to do any of these sorts of analyses, but it is important for you to at least understand some of this and to be able to look at different data sets and at least know whether or not the information is being represented accurately or at least somewhat accurately to you. And for those of you that like data analyses, maybe this is just a bit of a taster of what you can experience. If you were curious about it, there's lots of information on the internet, different things that you can watch. The Khan Academy has some terrific information, lots of YouTube videos on understanding statistics, things for you to look at, okay? And this is, you can explore this, take a look at those of you that understand statistics, this will make sense to you. Those of you that don't, basically see because of that range of data that you don't trust it with that long tail up the top there. I know, it's just a statistical joke. Discussion points. You'll notice for this unit in your Moodle shell, there's only one discussion thing. So we've combined units 9 and 10 because it is all about analyses. And I just want you to think about which you personally prefer. Do you prefer working with qualitative information or quantitative? Maybe you don't have a preference, but whatever the case may be, after you've had time to think about both, after you've completed that Unit 10, respond to this discussion question and really let us know which do you prefer, with at least 3 reasons why you do or do not like, or why you like that particular type of data analysis. Okay, that's it for this week. By the way, these pictures are from Quebec City. So if you ever get the opportunity, beautiful place to visit and a great place to be. All right, have a good one and take care, everyone.